Hello and welcome to Cybersecurity's new series, Get to Know Your Logs. My name is Lee Arkanal and I'll be shedding some light on some event IDs and what information they bring to you as a threat hunter, SOC analyst, or whatever role you're filling in your organization. I'm going to be explaining how that they have helped me threat hunt and how they can help you in the future. So let's dive right in. So before we get started and diving into the technical details of the logs and what they're telling us, I want to talk about why are we doing this? Why is this series being created? The main reason is as a threat hunter and SOC analyst, I need to know what the logs are telling me that I'm getting alerted on. What information can I pick from each log? Also, there's a lot of logs out there that might not be being ingested by your organization. And if you know those logs exist and you know the information's in there, you might be able to build a use case to say, hey, this certain log looks for RDP traffic, and we could really use that in our SIM or our EDR or whatever tool you're using. And I'd like to share that knowledge that I have and experience as a SOC analyst and currently a threat hunter. If you don't know the log exists, how are you ever going to find that threat? But so I hope you enjoy this. I really enjoy logs in general. And I hope that I can help your organization and you become better threat hunters. Now, to get the series started, you'll notice my log list. And these are event IDs that I have prioritized based on value add and how common I've seen them in threat hunts or attacks. Also, you'll notice there's a lot of Windows event IDs or Windows-based IDs for endpoints. Now, the logic is that a large portion of organizations and enterprises are running Windows for their standard users' computers. Now, later in the series, I plan on expanding out, but we're going to start here. In part 1, which is this part, you're going to see the process create logs, which is Windows Event ID 4688 and Sysmon Event ID 1. Also, we'll be touching on some PowerShell logs because they bring a lot of information in certain circumstances and can be very powerful. Part 2, you'll see registry key events, which is Windows Event IDs 4656 and 4657, or Sysmon Event IDs 12 and 13. Now, they have a special relationship with each other, but we'll talk about that in part 2. Files being created, specifically Sysmon Event ID 11. This can be really powerful when looking for certain extensions, but once again, we'll talk about that in part 3. Network connections, Sysmon Event ID 3. Pipe names being created, Sysmon Event IDs 17 and 18, track that. And then RDP log event IDs 131, 132, 140, and 148. All right, well, I hope you enjoy and stay tuned for the whole series to find out. So first up is Windows Event ID 4688, and here's an example of that. Some of the information that we can pull from this log is the new process name, creator process name, the user, and the token elevation type. Now, some EDRs and XDRs run with a parent-child relationship when it comes to processes. So in this case, new process name would be the child process, while creator process name would be the parent process. The token elevation type, looking up at the Microsoft documentations, this is what I found, but the $% sign 1936 is used if UAC is disabled or user is built-in admin. I see a lot of service accounts alert for this, while 1937 is running as administrator, and 1938 is the standard user token. And I will show you the differences between 1937 and 1938, and I'll demonstrate that in the lab portion of this video. So here we have an example of Sysmon Event ID 1, which is the equivalent to Windows Event ID 4688. Now, Sysmon is like an aftermarket logging that you can install after you've already installed Windows OS. So it's aftermarket. But it's really powerful endpoint logging and looks at some stuff that the Windows native event logging does not. So if you're curious, Google Sysmon is part of the Microsoft sysinternal suite, super powerful tool. I'd recommend looking into it or at least getting knowledgeable about it. Information you can get from this log is the image and the parent image, which once again, child process and parent process, the username, and the integrity level, which is like the token elevation type. But here we have medium and high, which is, medium is the standard user and high is the admin. Something that I also noticed is that there are hashes involved. Now you have to configure sysmon correctly to get these, but those can be really powerful whenever you are threat hunting and you actually find a malicious executable. If you find the hash, then you can start looking throughout your environment for that hash to see if there's any more. But other than that, super powerful tool. Go take a look at sysmon. Before we get to the demonstration portion of the video, I want to spend some time and talk about the methodologies behind the tactics and techniques that I'll be using to generate the logs we'll be looking at. So the way this is built is we're going to complete some very basic tasks in the beginning, and then we're going to slowly work our way to some more complex actions that actually might look like threat actors on your endpoint. Now, the reason we're starting with some basic things like opening Word from a start menu is that if you know what normal looks like, then you can start to pick out what abnormal looks like as well. And that's a good foundation to have, especially when looking at logs. All right, so let's look at what opening Word from start menu looks like. If you look at the creator process name and the new process name, you can see that explorer.exe was used to open new process name winword.exe. Now, you see it in Windows Event ID 4688, and you see it in sysmon Event ID 1. Now, you can look at the integrity level and the token elevation type, and you see that this was created by a standard user. Now, the next thing we're going to do is we're going to ping through command.exe, but we're going to change some things up. All right, so let's get going. So the next task involves us running a ping command from command prompt. And we're going to do that twice. First as a standard user, second as an admin. What this is going to illustrate is the parent-child relationship between command.exe and ping.exe, as well as we can take a look at the differences between the token elevation type. Now, when we run a ping command, we don't really normally think about what's going on because we type in ping, we put in the address that we want, and we get our results, and we move on. If we're troubleshooting, we keep moving on to the next step. If not, we're just happy. So what really happens is if you open up command prompt or PowerShell to run this task, those parent processes will actually call on ping.exe, and ping.exe is going to do all the work. And we're going to take a look at what that looks like and how we can detect on it. So going down the rabbit hole a little deeper, we next run into bat files. Now, bat files can be very simple, like in the example provided, or they could be extremely complex. Now, the goal remains the same. We're trying to automate tasks that we don't want to do manually. If you look in the example, a couple commands will trigger, and then we can find that in the logs. So when it comes to detecting bat files executing your environment, it starts to get a little tricky. If you look at the example logs below, we can see that the bat files can be found in the process command line field in Event ID 4688 and the parent command line field in sysmon Event ID 1. Now there's two problems to this. One, in Windows Event ID 4688, command line auditing is not on by default. So unless you have that configured, you're missing this piece of the puzzle. The second problem is sysmon is not Windows native. So if you didn't install that after the fact, you're also missing that piece of the puzzle. But I can show you how we can kind of work around this and detect what's going on. So for this bonus section, we're going to cover PowerShell script block logging. Now you may be asking yourselves a couple questions, like, I know I can use PowerShell just like command prompt, so why do we need specific logging to PowerShell? Why doesn't Event ID 4688 or sysmon Event ID 1 capture that activity? Well, the answers are, well, it does if you use the right things. If you use a normal ping command or, who am I, those will show up in 4688. But the PowerShell commandlets such as get item, get user, or new item that are specific to PowerShell, those won't show up in your standard Windows event logs. Also, you know how command prompt can use bat files? Well, PowerShell has .ps1 files that won't show up in 4688 or sysmon Event ID 1, so that's why we need these event IDs 4104 and 4103. And I'll show you a bit of that in the demonstration lab portion of it. To continue the PowerShell script block logging conversation, I wanted to compare and contrast some logs that we generated using PowerShell. Now what I did was I ran a general ping command from PowerShell. So what we should see is the parent process being PowerShell and the child process being ping.exe. Here on the screen we have Event ID 4688 and sysmon Event ID 1. You see everything matches up. Now looking at the next Event ID, which is 4104, we can see that 4104 also captures general commands like ping. Now what that means is feasibly we can detect this 3 different ways if we have all this logging enabled. Something that the process-created event IDs are blind to are PowerShell commandlets, which are commands that are exclusive to PowerShell only. This is where event ID 4103 and event ID 4104 really come to shine. Now, looking at the logs on our screen, you can see that 4104 grabbed the get computer info commandlet with a little bit of metadata. Now, if we look at 4103, this is where the real metadata happens. It gives you some information of what the command name was, what command type, if there was a script name, all this information that you can use to get an idea of what this computer looks like that is running these commands. And this gets really important when it comes to PowerShell downgrade attacks, where the attacker is using an older version of PowerShell to run commands, which are vulnerable to certain things. So now that we know a little bit more about the information that we can pull from PowerShell script block logging, specifically surrounding event IDs 4103 and 4104, let's talk about PowerShell script files, or .ps1 files. Like the bat file we discussed earlier, PS1 files contain scripts that can be run in PowerShell and normally contain PowerShell commandlets. When executed, they should generate event IDs 4103s and 4104s. So let's take a look at those logs. As you can see in event ID 4104, we executed a PS1 file named setRegKeyAudit. Now, what this contained is what you see. We see a get execution policy commandlet, as well as a set execution policy commandlet, along with some arguments and some more directories of what this is going to affect. So we get the entirety of the script file that was generated or that was executed. Looking at event ID 4103, we can see that the get execution policy commandlet was run. Once again, we get all the metadata surrounding that. But here's the thing. From this one PS1 file, it will generate many event ID 4103s, so you can actually have a chain of events, and you can use that in your investigation, which is actually really helpful. Now, one of the more confusing and complex things a threat actor can do is issue an encoded command. Now, Sysmon Event ID 1 and Windows Event ID 4688 will capture that if the command line auditing is enabled, and you'll get what you see in the example log. Now, don't worry, we can work with this and find out the initial command that was thrown, and I'll show you how to do that in the demonstration portion of the lab. So one of the more complex things and sometimes intimidating things that an attacker can do is execute an encoded command. Now, Event ID 4688 and Sysmon Event ID 1 can capture this, but you'll get what you see on the screen. Just a bunch of nonsense. Now, that doesn't stop us, because if we know or if we figure out what it's encoded with, specifically base 64, we can decode that and we can find out what information lies in here and then do like a backward analysis and figure out what command was run. We won't see what command is run, but we'll see the output of the command, and then we can figure out, hey, this person was pinging, or they ran a who am I, or they reached out to some URL. But we'll do that in the lab. Welcome to the demonstration portion of this lab. If you've made it this far, thank you for your support, and I promise you it's going to get a lot more exciting than the Death by PowerPoint section was. Now, this is the part where we're actually going to be completing some tasks to generate some logs for the threat hunting portion, which is next. As you can see on my screen, we have a couple tasks to complete, and they're basically set up from easiest to a little more complex. Alright, so let's get started with task number 1. So for the first task, all we're going to do is open up Notepad from the Start menu. Now, if you recall from the lecture, opening up anything in this type of fashion should result in an event log being created where the parent process is explorer.exe and whatever you're opening will be the child process. In this case, we should find a log that says parent process, explorer.exe, child process is notepad.exe. And that's it for task 1. Let's go to task 2. For task 2, we're going to execute a ping command using command prompt. Now in the lecture, I highlighted the fields that show the different level of privileges, and we're going to use task 2 to highlight that as well. And we're going to generate some logs from a standard user and from an admin. So the first thing you notice, if you look at the bottom command prompt, in the top left, you should see administrator and command prompt. This tells me that this is the admin level shell that we have. Also, it opens up to the directory C Windows System 32, whereas the top shell is the standard user command prompt. As you can see in the top left, it just says command prompt, and it opens up to the C users and current user directory, which at this point is James Murphy. So if you are an admin or you're working around, in your lab and you're just popping around different shells, this is a quick way to tell, what are you working with and what level privileges. So we're going to run a quick ping command. It's not going to be a long one, and we're going to target Google's DNS. But what we are going to do is we're going to keep the commands consistent so that we can compare apples to apples, and when we're looking at the logs, we can tell which one was the admin and which one was the user based off of the privilege that it has. All right, that's complete. Let's move on to task 3. For task 3, we'll be executing a bat file that I created. Remember that a bat file is a scripting language that command prompt can use to run or automate tasks. And as you can see, this is a very basic one that I created. It's really only running 3 commands. But if I wanted to do this every hour on the hour, I would create a bat file instead of having to connect and open up command prompt on my own. So the first thing you notice is who am I, netstat, and ping commands. These are the commands that we're going to run. The sleep 5 is a delay tactic where after who am I runs, it's going to wait for 5 seconds and then it's going to run the next one. That way, if you're collecting data, it doesn't just puke onto your desk. But this is what we're going to be running, and we have it over here. And you're going to see it run, and then we will generate the logs and we'll look for it later in the threat hunting process. But the time delay technique, that can be used by threat actors and malicious users to avoid sandbox detection. If you're working in a sandbox and you drop an executable or a bat file or something in it, if it has a sleep timer of like 3 days, normally a researcher or someone's going to stop what they're doing, kill that session, and just move on. Because really, who has 3 days to analyze that or sit there and wait for results? Or they could do that and move on to static analysis where they start breaking down the code. But that is pretty deep stuff. So if you're familiar with that, kudos, because I'm still getting into that. But that's a technique that threat actors have used in the past. All right, let's move on to task number 4. For task 4, we'll be executing a PowerShell commandlet to demonstrate the usefulness of the PowerShell script block logging and how to use it for threat hunting. Now, before we get into that, I want to throw out a caveat there and say PowerShell can run the same commands that command prompt can. For example, ping, who am I, netstat, the commands that found in our bat file, we can actually use PowerShell to run those too. Now, when we use it in PowerShell, what will happen is all the process create logs that we generate will have PowerShell as the parent process instead of command prompt. What this means is you can still find process create event logs from PowerShell. What you won't find is PowerShell commandlets in process creates, and I'm going to demonstrate that in this task. So first thing, we're going to ping our local IP address to demonstrate that we'll be able to find that in a 4688 or sysmon event ID 1. But now what we're going to do is we're going to run a get computer info. It's going to do its thing. And then later on in the threat hunting portion, we will search for that and find it in the PowerShell script block logging. All right, so that was easy. Now on to task 5. Finally, for task 5, we will be executing an encoded command in PowerShell. Now what this is going to look like is a string of random characters, because what we're doing is converting plain text to base 64. Threat actors have used this technique to obfuscate or hide what they're doing so that if a defender sees the logs, they don't know right away what they're seeing. So it could say something like ping, who am I, or it could be reaching out to different URLs. But I'll talk more about that and what to do with them in the threat hunting portion of this video. But right now, we have to complete a couple steps before running this command. And first, I'm going to run a who am I. We're going to get the plain text out of there right now. So for the encoded portion, we have to set a variable, which is, gotta spell that right, who am I? And then we are going to use this syntax, copy and paste it. And if we want to see what it looks like right now, we can run echo encoded command, and we're going to get this output. And that's what we should see in the logs. Now, to run it, we do PowerShell, no op, tac W, which is the Windows style, which is actually hiding it so it actually won't pop up. And hit run. And then it disappears. So we'll be looking for that in the logs as well, and I'll talk about what we can do with that and figure out what the attacker's doing. All right, so now it's on to the threat hunting portion. Thank you so much for making it through here, and I hope to see you on the next section. Welcome to the threat hunting section of this video. This is the part where we're going to take the theories that we built in the lecture and the demonstration portion of the video, and we're really going to put them to the test. We're going to jump into the logs, we're going to look at the fields we talked about earlier, parent process, child process, command line arguments, and we're going to really see if we can detect the activity and the actions that I took in the demonstration portion of the video. Also, you should pick up some little hints and tricks of the trade that we can use along the way to better ourselves. All right, let's get started. Before we get threat hunting, I have one last thing I want to tell you. We'll be using Splunk as our SIM, and we'll be bouncing around between Windows event logs and Sysmon event IDs. The logic behind that is that they capture most of the same information when it comes to process create events, and I wanted to show you that there's more than one way to skin a cat or detect maliciousness. All right, let's get started. For this first hunt, I'm going to take a little more time to explain the fields and values that we'll be looking at and what we can do inside Splunk for those of you who are unfamiliar with or new to Splunk, because there's a couple things that we can do to make the fields easier to understand and make the data look a little prettier. So for task 1, we opened up Notepad from the start menu. Now, the first thing we have to do in Splunk is we have to declare an index. And since this all happened on the endpoint, we have index endpoint. Then we're going to focus on event code 4688, which is the Windows event log that correlates to the process create ID. So now, next thing we're going to do is we're going to look at computer name desktop 2BB 001B, which is the desktop that I use in the demonstration. Now I know I talked about parent and child processes. Well, in Windows event logs, they have the names creator process name and new process name. So the creator process name is the parent, while new process name is the child. So knowing that, we're going to look for explorer.exe, as the parent, and then we are going to look at notepad.exe as the child, and we're going to run the search and we're going to see if it provides us with any results, because the last thing you want to do is do all this magic and realize that nothing's coming back because you spelled something wrong. Okay, so we have results. So the next thing I'm going to do is to make the fields a little easier to understand. We're going to take creator process name, and we're going to take new process name, and I'm going to rename them. So creator process name will be parent process, and new process name will be child process. Then the next thing I'm going to do is beautify the data using the stats command, where we are going to display the child processes by the parent process, so which child process was kicked off by which parent process, and the computer name. That way we can verify that it is actually my computer. Once we hit go, we look at the results, and here we are. We have parent process being explorer.exe, the computer name that I used during the demonstration, and notepad.exe being opened. So we can prove that the theory that explorer.exe actually opened up Notepad. All right, let's get on to task number 2. Task 2 had us executing ping commands from command prompt. And remember, we did it as a user and as an admin level, so we're going to pull out those values. Now, here's the query that we got, and it's a little loaded, but once again, I will walk us through it. So the first chunk stays the same. Now, the creator process name is in instead of equals. What that does is Splunk sets it up so that you don't have to put creator process name or computer process name or. What it does is you can create an array where you can say creator process name is in PowerShell or command.exe. It's just a little prettier. Then our new process name is looking for ping.exe. Once again, we renamed creator process name to parent process, new process name to child process, and we took the process command line and renamed it process command line just a little easier way so that you don't have to put all these underscores in it. Next is a line that we're looking for the privilege level. So it's going to evaluate the privilege level. So in case the value is 1938, then we're going to put out standard user. And if token elevation type equals 1937, then we're going to see admin level. It's a little easier to understand admin level than try to remember these values. Then finally, we're going to output the data in a way that we see the process command line, we see the parent process, and then we're going to group it by child process, computer name, and privilege level. This way we can tell the differences between standard user and admin level. So let's see what our results are. It's working, and we have results. So you can see that there's a ping command. This is the one that we used in the demonstration, the only two, and that level was admin level. Looking at the bottom, we see a little bit more. And do you remember why? Well, here is the standard user that we actually ran for task 2. Then later on, we used PowerShell to run a little test for the PowerShell script block logging. So not only did we find task 2, but we found a little more than we bargained for. All right, I hope this is easily understood. If not, if you have any questions at any time, post them in your comment. I realize this isn't a live video, but I will be looking at the video and commenting and answering those questions. So feel free to ask. All right, on to task 3. For Threat Hunt 3, we're going to take this a little differently, and we're going to start with a very general query, and then as the information comes in and we narrow it down by fields and values, we'll start to create a query that is a more direct detection. This is the process that I take during my threat hunting. Is, I have an idea of what's malicious, what's abnormal, and I start very, very wide and throw this big old net. And then once I cast it and bring back some values and data, I find out false positives and I weed them out, and then I have a smaller net because I know what I'm looking for now, and then I try and find maliciousness that way. So that's what we're going to kind of do. And if you recall, in task 3, we executed a bat file. So this time we'll be looking at sysmon data, so that's our index. We will be looking at event code 1, which is the process create. And we are going to look at the desktop that we used during the demonstration. And then we're just going to throw in a keyword .bat, which should find anything that has a bat file in it. So let's see where it connects and what data we get back. So we get 7 events, and we're going to take a look at the first one, and that's going to help us kind of understand what we're looking at. So scrolling down, the first thing we see is command line, which is ping 8888 with 10 times. And then the image is ping, which makes a lot of sense. Then we take a look at parent command line. So knowing that, we can think that command line is the child process command line that was run. And parent command line is this, which has the .bat file at the very end. So that's where it detected it. And then we're going to scroll down, keep looking for some different things. We have integrity level, which is medium. So I'm going to check that so it sends it to the top so that we can look at it easier. And we also have parent image. So just by looking at the data, we know that parent image is now the parent process, and parent command line is the parent process command line that was run. So image and command line, this can be renamed to child process and child process command line. So we're going to go ahead and do that. We're also going to pick out those values. So the first thing we're going to do, come up here and do some stats. Well, actually before that, we're going to take parent command line equals, and we're going to put the wildcard in there because we actually have a field. What this does is it actually speeds up the query and the search because it's combing through parent command line fields instead of just every single field. So it's more efficient. So we're going to go by image as child process, look at the values of command line, which are the child process command line, and we're going to group it by parent image and parent command line. Now, I'm not renaming those because they make sense and they're already labeled parent, just to be clear. Also, if we do pick up multiple bat files, because we're grouping it by parent command line, it should create its own grouping. That way we can see if there was one bat file only or it was a bunch. So we're going to run that. Hopefully I spelled everything right so we get things back. And looking at the data, it's working. Here we are. So our parent image was command, which makes sense because that's what bat files use to run. The parent command line was the get to know your logs bat file, .bat. And if you remember that we had netstat, we had who am I, and we had ping. Now this program data chocolatey bin, if you remember the sleep 5 command, that is the executable that actually times it out. So we found everything that was in the bat file, so we've been successful with that. So I hope you take mainly, the theory and the process behind this, where start big, start whittling down, and then finally you have the fields you're looking for in mind, and you have the activity, and you know exactly what you're looking for. So I hope you took a lot from this threat hunt. And with that, we're going to move on to threat hunt 4. Moving on to threat hunt 4, this is where we start to get into the PowerShell script block logging. And when we're talking about PowerShell script block logging, commands being run, there's 2 event IDs that we're going to focus on, and that's 4104 and 4103. Now, they both contain similar information. One's a little more robust, and I'll show you that. But 4104 you can think of as the remote command, while 4103 is the executing pipeline. And I'll explain that a little more and show you. So what we did was we opened up PowerShell and ran get computer info. And we're going to start with 4104 because it's a little less information, but it's really powerful anyways because, hey, it shows you the command line that was run. So here we can do 2 things. We can look at the fields that Splunk provides, or we can click show all 19 lines and we can actually look at the native log itself. So if you come down to the message, you can see where it was detected, and it says get computer info, and that's all in the message, which is great, and that's fine because that starts the hunt. Now if we come over to 4103 and have a different query, I'm going to run that as well. Remember, this is the executing pipeline. We can come down here, see that there's more than 19 lines, so a little more information, and we see once again message, get computer info, and then a lot of contextual information. What ran it, was there a script name involved, who was the user, and this is actually really powerful information, because if we kind of tweak this, and we're going to go back 48 hours, I think 48 hours, I think that's when I was doing some work, that's going to run, but instead of get computer info, I'm going to focus on set item property. What this can be used for is registry key modification, which is important when it comes to the configuration of Windows. And we'll get into that later because one of the logs that we're going to cover is registry log. So that's, we'll get there. All right, so we're looking at the first item that pops up. And if we look at the native log, what information do we see? We see message, and then we see a lot of all of this information. We see what the path was set to, what the name is, and what the value is, and if the force flag was set to true. The force flag is when you type in a PowerShell command. If you're an admin user, you could do tac force and make sure it happens no matter what, bypass all errors, and it'll be set. So here we can see that the value was actually set to true. Now if we come to 4104 and do the same thing, set item property, then we're going to move back 48 hours again. We're going to run that. We're going to see what we get with that. Oh, I said 48 hours. Forgot to hit apply. I do that all the time. Here you can see, once again, only 19 lines, a lot less. Here we have the actual command that was run and all the values and what it looked like as I was manually typing it. Go back to 4103 again, and it's really breaking it down into the programming and the parameter binding. for a set item property, which gives you more context. It may not improve your hunt, but it definitely gives you a better idea of what's happening. Okay, and on to the final hunt, which is the encoded command. Finally, for Threat Hunt 5, we'll be looking for the encoded command that we ran on Task 5. Now, you may be looking at the query right now and realizing it's kind of a mess, and really it's unnecessary, but I wanted to show you a little quirky thing about PowerShell. So what we'll be looking at is the index sysmon again. We'll be looking at event code 1 and the same computer, and parent image is going to be PowerShell. Now, the reason I'm going to do that is because we actually have a bunch of false positives in the lab, but I want to focus in on what we did. Now, if you look at the command line value ranges from just TAC E to TAC encoded command. So if we run a search, what this should do is find all the results that meet this criteria. And remember, this in is actually just a logical OR for the array of encoded commands. Now, looking at this, once again, the TAC E should have been sufficient enough to capture this. But what I wanted to show you is that if you run just TAC E or TAC ENC or the whole thing, PowerShell will still successfully encrypt or encode this command. So now that we found it, the next thing to do is to take that encoded command and see what the value is. So now that we have the base64 string, what do we do with it? Well, there's a handy site called base64decode.org that we can take in, drop it in, and hit decode, and we get the results. Now, there's some special characters that we can remove manually, or if you are good at regex, you can drop into Notepad++ or another text editor, and you can pull out the results. So as you can see, it's LexCorp at James Murphy, and we know that we ran the who am I command. Now, you won't always get something like this. You'll get some other information that you can use to further your investigation, but that's a handy tool that you can use whenever you have base64 strings. And that is it for our Get to Know Your Logs Process Create video. If you like what you saw, please leave your comments below or give me a thumbs up. And if you really liked it, subscribe to Cyborg's YouTube channel and join us next time where we discuss registry key modifications and how to detect those. Once again, a big thank you for showing your support, and I hope to see you next time.